Welcome to this video all about scatter graphs. You can find the PDFs with questions, clues and solutions at mathsupgrade.co.uk. The first question is a non-calculated question and gives us a scatter graph showing the maximum temperature and the number of hours of sunshine in 14 different British towns. We're told that one of the points is an outlier. We need to write down the coordinates of the point. So an outlier is essentially a data value which doesn't follow the pattern of points which are shown on the scatter diagram. So you can clearly see this is the outlier here. So we need to give the coordinates of that point. So to go across the bottom axis first, which you can see it's 10, and then go straight up and you can see it's 19. So it's 10, 19 there for 1 mark. Part B, for all the other points, write down the type of correlation. So ignoring the outlier, what's the correlation here of these points here? So the correlation is positive. You can see the gradient's positive, so think about y equals mx plus c. The gradient's positive, okay, so it's a positive correlation. In part C, we're told that in another town on the same day, the maximum temperature was 16.4 degrees Celsius. We need to estimate the number of hours of sunshine in the town on that day. So the first thing you should do, you should draw a line of best fit on your graph. So make sure you draw a line of best fit using a pencil and ruler. When you're drawing your line of best fit, then you need to find 16.4 degrees Celsius on this axis here for temperature and go straight across until you meet your line of best fit. So here's my line of best fit. You can see it's going through as many of the points as possible, and it's also got an equal number of crosses on either side of the line. 16.4 degrees Celsius is going from here, reach my line horizontally, go straight down and read off the value there. So for mine, it's around 12.8 hours. Yours may be slightly different depending on where you've drawn your line of best fit, but should be in that ballpark. Part D, a weatherman says temperatures are higher on days where there's more sunshine. Does the scatter graph support what he's saying? Give a reason. So you can see from part B, you knew it's positive correlation. So that means that as the sunshine increases, the temperature increases, right? So he's saying temperatures are higher on days where there's more sunshine. That is true. So I've said there's a positive correlation generally. And that whole question there was worth 5 marks. The rest of the questions in this booklet are all calculated questions. In question 2, Sean has plotted information about 10 rugby players. He's plotted the points correctly, but there's 2 things that are wrong with his answer. So you need to look really carefully and describe what those 2 things are. The first thing you should notice is his scatter graph. His line of best fit is going from corner to corner. It's unlikely that your line of best fit will go from corner to corner. His line of best fit should be following the pattern of crosses there. So it should be going in that sort of direction. That's the first thing. The other thing you'll notice are his axis, his bottom axis specifically. His bottom axis here is going from 200, then 190, 180, 170. So it's going down in tens, then suddenly it drops down by 20 here. So the scaling of his bottom axis isn't consistent. Okay, so that's what I've written there, and that's 2 marks for that question. In question 3, we're given a scatter graph showing maths test marks against science test marks. We're told that Jamie got a mark of 34 in the science test. Using the scatter graph, find an estimate for his mark in the maths test. So in this question, you need to draw a line of best fit using a pencil and ruler. Make sure your line of best fit goes through as many crosses as possible and has an equal number of crosses either side of it. So it would be something like this. What I'm now going to do is going to look at the mark of 34 in the science test. So here's science test mark on the bottom axis. 34 is here, so go straight up with a ruler vertically until you reach your line of best fit. Then draw a line straight across and read off the value there. So the value I've got on mine is around 38 for my math test. Yours may be slightly different depending on where you've drawn your scatter graph's line of best fit. And that's 2 marks. In question 4, we're told that Jean records the maximum daily temperature each day for 10 days. She also records the number of children going to a paddling pool for each of the days. She draws a scatter graph for that information. We're told that Jean's information for one of the days is an outlier. Give a possible reason for having an outlier. So you can see this information here represents the number of people that go to a paddling pool, the number of children that go to a paddling pool, depending on the temperature. So you need to think of a reason why, on a day when it's very hot, why there may not be as many children going to the paddling pool. Okay, so there's lots of reasons you could give. One possible reason is that the paddling pool may have been closed for part of the day. So it may have been open in the morning and it may have been closed in the afternoon. Okay, so that's part A. In part B, you asked the type of correlation the scatter graph shows. Well, you can see it's got a positive gradient. So think back to linear graphs, it's got a positive gradient, so it's positive correlation. In part C, you need to write down an estimate for the number of children that went to the paddling pool on the 11th day when the daily temperature was 19 degrees Celsius. So the temperature is this bottom axis here. So find 19 on this axis, then go vertically till you reach your line of best fit, then go straight across, and you can see my value here is 17 people. The 17 people is my estimate for the people that went to the paddling pool on that day. The last part of the question says, it wouldn't be sensible to use a scatter graph to predict the number of children going to the paddling pool on a day when the maximum temperature is 13 degrees. Give a reason why. So why wouldn't 13 degrees be a good temperature to predict the number of children? Well, all my data here on this scatter graph is all from 18 degrees Celsius to 24 degrees Celsius. So it's in that range there, from 18 to 24. Anything which is outside of that range, right, may not follow this correlation. It may not follow this pattern. Okay, so even though this is a fairly straight line for this data, it may not be a straight line for 13. Okay, so that's my answer here. And the whole question there was worth 4 marks. In question 5, we're told that Katie measured the length and width of 10 pine cones from the same tree. She drew this scatter graph here, but we need to describe an improvement she can make to a scatter diagram. So the obvious thing she can do here is she can adjust the scaling on the axes. The way she's drawn the scatter diagram, all the crosses are bunched up in the top right hand corner here, right? But we can see the smallest length that is represented is just over 4 centimeters. And the smallest width that's represented just over 3 centimeters. So she could have started her axes from, she could have started with 3 on this vertical axis here, and she could have started with 4 on this horizontal axis here, and scaled it appropriately. So that's the answer that I've written here. There's a lot of wasted space in this part of the graph. In part B, the point representing the results for one of the pine cones is an outlier. Explain how the results for this pine cone differ for the other results for the other pine cones. So think about this outlier here. This is the one. Okay, so describe the length and width of this one compared to the others. So what I've got here is that despite having a length of nearly 6 centimeters, so there's length 6 centimeters, the width is only around 3 centimeters. The width of the others is about 4.5 centimeters. So that's my answer there. And that's 2 marks. Question 6, we're given a scatter diagram for information about 10 students. It shows the number of hours spent revising and the number of marks they achieved in a test. One of the points is an outlier. Write down the coordinates of the outlier for 1 mark. So this clearly here is the outlier. So the coordinate is going to be across and then up, so it's 4, 10. So there's the coordinate there. For all the other points, draw a line of best fit and describe the correlation. So ignoring this outlier, let's draw a line of best fit, which would be something like this, and describe the correlation. So the correlation is clearly positive. So think about y equals mx plus c. It's got a positive gradient, so it's positive correlation. And now I'm going to talk about what this correlation means in terms of practical terms. So in real life, what it means is the greater the time spent revising, the greater the marks that the student achieved. So for example, this student here spent more than 12 hours revising and achieved nearly full marks. This student here only spent 2 hours revising and only achieved 25 marks. So the greater the time spent revising, the greater the marks. In part C, a different student revised for 9 hours estimate the mark this student got. Right, so 9 hours spent revising this axis here. Go straight up from 9 vertically till you reach your line of best fit, then go straight across, read off that value there. So that value there is 63 marks. That's for my line of best fit. Yours may be slightly different. In the last part of the question, for another mark, we're told that the Spanish test is mark out of 100, and Lucia says, I can see from the graph that I'd revised for 18 hours, I would have got full marks. You need to comment on what she says. So, first of all, is 18 hours in the data range. Our data range here, from this graph, is between 2 hours and 13 hours. 18 hours is not within that data range, right? So that's why it'll be not a good idea to use this graph to work out the number of marks that she would have got. That's what I've put here. The line of best fit is based on the data range up to 13 hours. It would be inaccurate to extrapolate to 18 hours. So this word here is really important. It means to basically use data which is outside of that range. So the whole question there was worth 5 marks. In question 7, this scatter graph shows information about 10 snakes. So you've got their length against their weight. We're told a snake has got a weight of 740 grams. You need to estimate the length of the snake. So the first thing you do is you draw a line of best fit according to the data here. So make sure your line goes through as many points as possible and has an equal number of points on both sides. Then you need to go from the weight of 740 grams, the weight is this axis here, 740 straight across horizontally until you reach your line of best fit, then go straight down with your ruler and read off the value there. So on mine it's around 78 centimeters. Yours may be slightly different. The next part of the question, for 1 more mark, Stephen wants to estimate the weight of an adult snake of length 110 centimeters. He says he's going to draw a line of best fit and read off the weight at 110 centimeters. Explain what's wrong with his method. Well, if you look at the data we've got here, all the data on the scatter diagram, the length varies from 60 centimeters up to around 100 centimeters. So that's the data range that we've got for this data. If he's going to try and work out the weight of a snake which is 110 centimeters, 110 centimeters would be in this range up here, and that's out of the range of this graph, right? So it wouldn't be a very accurate extrapolation. So the plotted data has got a longest length of 100 centimeters. 110 is not in that data range, so it'd be inaccurate to extrapolate beyond 100. And that's 1 mark for that question, 3 marks altogether. In question 8, we're given a scatter diagram showing the time taken to run 100 meters against the age of different people. We need to first of all write down the correlation. So you can see the crosses here are going downhill, downwards, so that's negative correlation. In part B, we're told a student is 11 years old. The time to run 100 meters is 12 seconds. The point representing that information would be an outlier, and explain why. So 12 seconds if she's 11 years old. So here's 11 years old, and 12 seconds would be here. So that is clearly an outlier. The data's in this region here, and this cross would be over here, so it's clearly an outlier. Right, so she wouldn't fit that relationship of that data shot. In the next part of the question, for 1 more mark, we're told that Debbie is 15 years old. Debbie says the scatter diagram shows that I should take less than 12 seconds to run 100 meters. So you need to comment on what Debbie says. So the problem with the data is that we've only got data from 10 years old to 14 years old. So if she's going to be 50, if she's 15 years old, that's out of range of the data on the scatter diagram. So extrapolating anything beyond 14 years would be inaccurate. And that whole question was worth 3 marks. In question 9, from a survey, the outside temperature and the number of units used were recorded for 10 homes, and the scatter diagram shows that information there. So Molly says, on average, the number of units of electricity used for heating decreases by 4 units for each degrees increase in outside temperature. Is she right? Show how you get your answer. It's actually saying that every time the outside temperature goes up by 1 degrees, the number of units decreases by 4 units. Right? So we need to check that. We're going to check that by first of all drawing a line of best fit, okay, on this data, and then we're going to find the gradient. The gradient will tell you how much the units change for each degrees Celsius. Okay? If you're not sure on how to find gradient, be sure to check out my video file on gradients on this channel. So here's my line of best fit. Gradient is given by the change in the y distance divided by the change in x distance. So for this triangle here, it's given by the height divided by the base. I can draw this triangle as big or as small as I want to, and I can put it anywhere I want, as long as this line is the diagonal side. So for my triangle here, the change in y is 50, and the change in x is around about 21. So if I divide those numbers, I'll get around about 2.4. So what that says is that the number of units decreases by around 2 or 2.5 units for each degree Celsius. So clearly she's wrong, and that's 3 marks. In part B, it says you should not use a line of best fit to predict the number of units of electricity used for heating when the outside temperature is 30 degrees. Give a reason why. So 30 degrees would be over here. Our data is ranging from 0 degrees up to around about 20 degrees. 30 degrees is outside of our data range, so it would be inaccurate. Our line of best fit is only accurate up to 20 degrees. And that's 4 marks for that question. Question 10. Oliver's recorded the distance from London to 8 different cities. He also records the time taken to fly to each of the cities, and the scatter diagram shows that information. So we're told that Chicago is 4,000 miles from London. By drawing a line of best fit, we need to estimate the time taken from London to Chicago. So let's draw a line of best fit first. Here we go. Now, if Chicago is 4,000 miles, well, here's 4,000 miles, so we can go straight across from 4,000 horizontally with a ruler, reach a line of best fit, then we go straight down with a ruler vertically and read off that value there. And that's the time in minutes. And for mine, it's around about 495 minutes. Yours may be slightly different. Why is our answer only an estimate? It's only an estimate since it's based on the relationship predicted by the other flights here. Right? So this flight for Chicago may be slightly different. Okay? That's why it's only an estimate. It's not the exact answer. Part B. First of all, find the gradient given by the line of best fit. So if you're not sure on how to find gradient, be sure to check out my video on this channel. Gradient is essentially given by the change in the y distance divided by the change in the x distance. So I need to draw a right angle triangle anywhere underneath the line. I can draw it as big or as small as I want to. Best to draw it as big as you can, that makes it more accurate. So I've picked this point here, which is easy to read the values of, and this point here. Again, it's quite easy to read the values of here. So the change in y, 6,000 subtract 4,500, and the change in x is 700 minus 545. If I divide those through with the calculator, I get 9.7. So now I need to interpret the gradient. Okay. Well, the y distance was the distance. So the change in y was the distance in miles, and the x distance was the time taken in minutes. So if I divide distance by time, you should know that gives you speed. Okay, from compound measures, it's speed. Speed equals distance divided by time. So this is miles per minute. Look at the unit here, miles per minute. So this here is 9.7 miles per minute. So that's the speed at which those planes would have been travelling as an average. The whole question is worth 6 marks. So that's the end of this video. If you struggle with any aspect of these questions, be sure to check out my other videos explaining how to find gradients on this channel. Thanks for watching.